Hi, Tim with After Later Audio. Today we are going to look at Pachinko. Pachinko is just a really great source of all sorts of different random signals. It is based off of the Mutable instruments marbles. The only difference between Pachinko and marbles is the name and the size. The functionality is the exact same. So because it is just a smaller version of the exact same module, we like to refer people to the Mutable Instruments Manual because it is the ultimate authority on it. But we get a lot of questions about it, so I'm going to do a general overview of this module in today's video. But for more information, there will be a link to the manual in the video description. Let's dive in. All right, so let's look at Pachinko here. Real quick, Pachinko is it's basically just a random control source that is bonkers. You can do some audio rate stuff with it, but it really shines brightest as gate and CV outs and all sorts of different types of voltage options and really, really cool control over them. So, as the manual says, the T section or T generator produces random gates, and these are based off of what they call a jittery master clock. So you can see jitter here. Oh, and one thing to note too is T2 is the clock output. So whatever your rate knob is at, that is a constant clock signal from the internal clock here, which is also controlling the voltage side. So the clock here, it generates two different streams of random gates, which are derived off of itself, which are T1 and 3. So once again, your rate knob, that's just your speed of your internal clock, 120 BPM at 12 o'clock. And then here is our clock range, so you can divide or multiply. So you see green is the top. Again, with this, if all of these are set to green, that means they are in the top of the three little icons here. So here is a divide by 4 times 1. So I think this is where it's at 120 BPM. I said it was the red mode, but I believe it's the orange. So that's times 1 and then times 4. Okay, so after we talk about our divisions and multiplications here, let's just go to times 1. Once again, your random gates on T1 and 3 are derived from the clock on 2. And then how those are derived depend on what mode you have selected here. Okay, so let's talk about the different ways you can bias the control. So there's the bias knob. And then we have this button here and these three different icons, and those different settings, the green, orange, and red, they just basically have different ways of dividing up how the T1 and T3 are generated off of the clock of T2. So if we are in the green mode here, that is like the coin toss. So at every pulse of T2, there is a digital coin toss to decide whether or not that gate is sent out to T1 or T3. And then the bias controls the quote-unquote fairness of that clock, or of that coin toss. So let's actually go fast so we can see this in real time. So if I have it all the way to the left, you can see it's favoring T1 completely, and you're not getting any outs on T3. If you go to noon, then it's a fair coin toss, so it's really just a 50-50. And then of course all the way to the right, you're getting just the T3. And then so the orange mode here, this is T1 and 3 being generated by respectively multiplying and dividing T2 by a random ratio. So if you turn the bias knob fully clockwise or counterclockwise, you'll reach more extreme ratios. So you can see going all the way to the right doesn't fully take T1 out of the equation like it did in the previous mode, but you can see that T3 is happening a whole lot more often. And then of course, if you go to the left, that will flop that to T1 being more heavily favored, and then in the center it is more fair. So actually in this mode, if you have your bias at noon, you're getting a constant clock out of all of them. So this is like a cool mode, not so much for percussion, I don't think, but maybe for just like kind of triggering different control voltage sources, and then you can move this around and just get some variation within your patch there. And then finally, this is my favorite mode here. As far as the bias goes, this basically, it uses the T2 clock and it alternates between T1 and 3, following the same kind of regularity that a kick and snare drum would. So depending on where your jitter is and where your bias is, you can get different types of drum beats. So I like to put T2, usually mult it, but I like to put T2 out to a hi-hat, and then T1 and 3 into a kick and snare, and yeah, get some cool beats. Why don't we actually patch that up really quick, because that will help us get our heads wrapped around the jitter mode as well. So yeah, I'll be back in a flash. Okay, so now I have I've got the T1 controlling the bass drum here, the T3 controlling the snare on the PK, and then I've got T2, which is our clock going into the knit, which I'm going to use as some hi-hats. So let's turn that up in the mix. So pretty simple beat. We can go through our different time divisions here. So that's pretty simple. Let's go back to the fast one because it's pretty fun. And then the bias control, like I mentioned earlier, in the red mode here, will kind of dictate which is more favored, the bass or the kick. So if I go, or excuse me, the snare or the kick. So if I go to the right, cool way to change the beat up a little bit. Get more bass hits here. And then let's just look at the jitter knob really quick while we're playing this beat. You can almost get into like some swing territory. Here. And then of course, if you go all the way up, it's just chaos. However, what's cool about this chaos is it is actually still in perfect time with the internal clock, even though it sounds crazy. So you can actually get into some pretty cool like IDM type territory here. And I think if you're going to use the jitter really extremely, then using multiple hat voices, like hi-hat voices, would be a really great use for that. But yeah, let's stop this patch here because it's not that interesting, and let's talk about that jitter functionality in more detail. So the idea here, basically, of the whole module and what the jitter is trying to do is trying to simulate a human playing some sort of percussive instrument, and then as you turn the jitter up, it kind of, you can think of it as a drummer who loses count and then quickly catches back up to the beat. So maybe they're playing a straight 4/4 and they lose it a little bit, but they can find their way back to it the next measure. So that's the idea here. And like I said, all the way up just turns it to just absolute chaos. And then depending on what mode here you're of course going to get some different outcomes. But if you're in the red mode, which is like the drumming mode, which I'm not sure if I mentioned yet, but if you're in the red mode, the T side basically becomes just like a grids, except for without a few of the CV controls and the accent outputs, but basically just a really solid beat generator. So yeah, that is the T side as far as controls and outputs go. I will talk about these buttons up here when I get to the Deja Vu section. Of course, there's CV in for the bias, so you can actually control your fills and everything with CV. There's you can put a clock in, and you'll notice there's a clock in on both sides. We'll talk about that in a moment. But basically what the clock in does is replaces the internal clock with whatever is happening externally, and then the T2 will mirror that. Something else to notice or to keep in mind with the external clock input, when a signal is patched into that, the rate knob then gets repurposed, and it becomes a division multiplication control, and then the jitter setting is applied to the external clock. So even though you're clocking it externally, the jitter still does have control over that kind of craziness that's happening here. So before I leave the input section of the T side here, just know that the bias and the rate all scale 1 volt per octave. So if you get this thing at an audio rate, you can send it quantized voltages, and it will sound like a little oscillator. And the final thing I'll talk about for just the T side here is you can actually adjust the gate length for the T1 through 3 outputs. Notice this button, or this LED here, is blinking. That's because I held this button down. So let's just get out of that really quick. So now we're in our standard mode again. But if I hold this button down until it blinks, now I can adjust the gate length. So with the bias knob all the way down, we have a 1% for our gate length, and you can go all the way up to 99%, so you can get longer gates. What's really cool about this is the jitter knob. When you're in this gate adjustment mode, you can use the jitter knob to adjust the randomization of the gate length, which is really interesting. So all the way up is just complete randomization, just totally chaos random, and then this is a little bit more deterministic in how it chooses the randomness of the gate length. Okay, so moving on to the X side, the X generator generates 3 independent random voltages output on X1, 2, and 3. They're clocked by the 3 outputs from the T section, or by a common external clock. So T1 clocks X1, T2, and T3 respectively. Notice you can just externally clock the CV side or just the T side. So if you clock the T side and not the X side, then you are still going to be following this side. You'll just be following what you have clocked in externally. So just like the T side, the X side has a couple different push button sections that each have 3 different modes. Okay, so we'll talk about the spread or the probability distribution, and this has to do with your output ranges and your shapes. So basically what you have here is if you turn totally counterclockwise from 12 o'clock, the voltages are increasingly concentrated near the center of the range, which you can select here with this button, which we'll talk about those different ranges here in a moment. So at fully counterclockwise here, a constant voltage is output. At 12 o'clock, the voltages follow a bell curve depending on the distribution chosen here. Well, a bell curve in relation to what you have chosen here as the distribution. At 2 o'clock, they occupy the entire voltage range with equal probability, and then past this point, extreme values become more likely. So fully clockwise, only the minimum and maximum voltages are possible, turning X1 through 3 into random gates. So you can actually turn this into 6 different gates instead of just the 3. So that's pretty useful. And then you have your distribution bias here, which again has its own little section here, which is a little more simple than this, so I'll just explain it. You have your +2 at green or +5 voltage range, and then at red you have -2 to +5 for your voltage ranges. So if I go to the red setting here, you can notice that X1 through 3 are cycling between a red and a green LED color. That just means red negative, green positive. So what this bias does is it skews the distribution towards low or high voltages. So you can think of this as an equivalent to an offset. It doesn't shift the voltage down or up, but biases the decision towards the bottom or top of the voltage range. So if you have this, the +2, you're never going to go above +2, but the further to the right or clockwise you have it, the closer to the top of that range you're getting, and then vice versa here. Okay, so let's talk about this section here for our different basically just the different types of outputs we can get from the x1 through 3. So if you have it set green, you can see it's just three equal lines in a row. That means all the channels follow the settings on the control panel. So if you're in green, all of this applies to all three of these. So the orange mode here, where you can see the middle line is the longest and then two shorter lines on each side, that means X2 follows the control panel, while X1 and 3 take opposite values. So if you have the stepped voltage all the way up and you have the orange mode chosen, that means that X1 and 3 will be smooth voltage outputs, while X2 will be quantized to the root note and its octaves. So if you're using this as to control your 1 volt per octave on an oscillator or anything else, you're just going to get the low and high octaves of whatever range that you're in. And then the red mode, this is where X3 follows the control panel. X1 reacts in the opposite direction, and X2 always stays in the middle. So one thing to note about the X side here is, of course, we do have our CV control here. So you can control these knobs, obviously. So this button here, what this does will actually make it so you can process external CV to sample to use as your source for the random outputs here. So you press this button. Let's just throw a nice LFO. You put that into the spread, and now we are generating these random signals based off of this LFO that's going in, rather than the internal CV generator here. A couple of notes on the external CV processing. The bias acts as a transposition control, so that'll shift voltages up and down. And then spread, notice that we are using the spread in, so it's not going to behave the way it usually does. What that does, it controls the range of this transposition. So when you have an external CV being sampled to create your random signals, know that your X section's clock input is not being clocked, so it's still being generated internally. And what happens here is the 3X outputs will all contain the same melody or the same group of CV values. However, the outputs 1 and 3 will have some of the notes frozen or sustained, because each one of these is actually sampled at its own rate based off of what's going in there. That sounds kind of confusing, but yeah, it's just a really cool feature. So one other interesting little mode here is if you have green selected here in your channel diversity or output diversity, and then you actually have external CV going in and an external clock. Let's see, do I have a clock somewhere? Here we go. Then basically it turns it into a shift register. And what that means basically is X2 carries X1's voltage shifted by 1 clock tick, and X3 carries X2's voltage shifted by 1 clock tick. If that was kind of confusing, then I suggest you go check out some information on shift registers. So the steps knob here, it basically controls the horizontal and vertical steppiness of the generated voltages. So at 12 o'clock, it generates the typical sample and hold type steps. If you turn it counterclockwise, you can get smoother edges, and then random linear segments, and then smooth random curves. Turn totally clockwise to quantize the generated voltages to a scale, and then to progressively strip the notes of the scale until it's only at its root elements. So really quick, if we're up here, that's our sample and hold style. As we go over to the right here, we start getting a quantized scale in its full note range here, and then as you turn it further and further to the right, it starts eliminating more and more of these notes until all the way to the right, you're basically just getting the root note of that scale. What's really cool about this is you don't need a quantizer, because this actually quantizes voltages for you and has a bunch of different options. So why don't we take a look at that? Okay, so let's talk about the built-in quantization on Pachinko. Factory preset has it set to a root note of C, and you can change that, but let's just talk about changing the different scales. There are 6 different scales. So if you hold this button down until that starts blinking, basically this is where you choose your different scales. So at a blinking green, that's a major. Blinking orange, we got a minor. Blinking red, we got a pentatonic, and then a fast blinking green is gamelan, and then a fast blinking orange is rag Bhairav. I don't know how to say that correctly. And then fast blinking red is rag Shri. So you have these cool different quantizers in there. So you don't technically need an external. You can program your own scales into this, but it's a pretty involved process. So I would suggest, once again, hitting up that manual on the Mutable Instruments marbles, linked here in the video. So at first glance, you might think that Pachinko has a gate side and then just an X side, and those are the 2 output sources. But there's actually a third source here, which is the Y generator. And the Y generator, by default, is a smooth, full-range, -5 to +5 volt random source. It is clocked at 1/16 the rate of X2. However, you can adjust these settings by holding down this the spread button here, and then adjusting the spread, bias, steps, and rate. So you can pretty much apply all of these different parameters that we talked about already to the Y output. So that's a good way to get this thing to really be in sync, or really behave in the way that you want it to in relation to all these, depending on what you're doing with it. Are you making drum beats, or are you just controlling different CV sources, or, you know, the sky's the limit. So here, the Deja Vu section, it's pretty sweet. Basically, it's a way of if you like something, say you get a nice sequence that you like out of here, you can lock it in and then have that sequence repeat. But you can kind of go above and beyond that. But first up, let me just tell you that if you don't have either the T or X buttons illuminated, then you're not using the Deja Vu section, and you can do them independently of each other. So you could get one side repeating while the other side stays random, and vice versa. But basically, whenever the module needs to make a random choice, for instance, to decide on the amount of jitter to apply on the next tick of its clock, or to generate a random voltage for one of the outputs, it queries the Deja Vu section. So the Deja Vu section either recycles a previously generated random source, or samples fresh random data from a hardware random source. So what does this mean? Well, let's get into it. Like I said, these control whether the Deja Vu settings apply to the T or X, or neither or both. So the module can generate a non-repeating sequence of voltages while it's locked on a looping rhythm. So that would be T enabled and X disabled, or the exact opposite. So you can get a totally random drum beat going and a repeating sequence. What the knob does here then is it adjusts the probability of recycling random decisions or voltages from the past. So from 7 o'clock to 12 o'clock, this probability goes from 0, completely random, to 1, locked loop. So you can tell you're in a locked loop when these are blinking. So that means if you're here, if you have both of these selected and your Deja Vu knob is at 12, then the module is thus stuck in a loop because it never generates fresh random data. So from 12 to 5 o'clock, the probability of randomly jumping within the loop goes from 0 to 1. So here we have a nice repeating loop. Rather than disengaging our Deja Vu section, what if we want to slightly change our melody, or keep the same notes and same type of beat that we have, but we don't want to go fully back into random territory? Well, then that's what the Deja Vu knob is going to help us out with. Then, of course, we have a Deja Vu CV control, so a well, let's just check it out. Actually, this if we have a bipolar source, then what that's going to do is basically just bring our Deja Vu knob either counterclockwise or clockwise. So that's very, very useful. And then finally, the last thing to acknowledge here on the board is the steps, and or the length. And I imagine you can put together what that is. Basically, it goes from 1 to 16 steps. So if we say we lock in a 16-step sequence that we really like, well, we could bring that down to an 8. So that's just yet another way you can control something that's the same or looping, but add some variation by adding and subtracting steps. And then one final thing to mention about the Deja Vu section, it has no effect whatsoever on the Y generator. So you can lock all this stuff in, but you can still retain complete randomness here off of out of the Y output. So now that that is all said and done, that's a lot of information to take in. Why don't we just build a couple little patches and see it in action? Okay, so we got a nice big rat nest of a patch here. Why don't we just play it and then go through it? So I'll bring it up element by element. I'm using the PK here, just like earlier, as a kick and snare. So we'll bring that kick up. And then the snare. It's a nice little groove already. Then I'm using the knit for hi-hats. So right off the bat here, these are the 3 gate outputs from Pachinko in that drum mode that I mentioned earlier, controlling the kick, snare, and hi-hat. And then I've got the second output of knit going into a Q-Pos here, so we can get a little bit of variation. I'll skip these two because the Atom is up next, and it is kind of doing double duty as percussion and melody. I've got one side of Atom running into the 2 HP freeze, so that's giving it some glitchy. And then I'll throw the non-glitchy one into the effect send, into the mimeophone here for some delay and reverb. And then finally I've got the rings going here, and I've got one channel going straight into the mixer and then one going into the cutting room floor here, which is buried under a rat nest from Recovery Effects. It's kind of like a dirty delay that has some warbly stuff going on, so let's just turn those up in the mix. Here's the first one that's straight into the mixer, and I'll throw that into the mimeophone as well. And then finally the cutting room floor. So I'm using the CV outs from Pachinko to send 1 volt per octave information to Atom, rings, and knit. Even though knit isn't really all that melodic, it's still in key and changing pitch ever so slightly with the other two. And you can see I've got that molted out here, so I've got a lot of double duty here. But what I like to do is send the clock out into a molt, and then I'm using this ornament in crime over here as a clock divider. So I'm actually just getting a half speed of the Pachinko clock, so I'm being able to distribute that around. So I'm actually triggering Allen with that and using the Morecoming and Enigma expanders for extra gates and extra CV. So yeah, just all starting from Pachinko, just building this whole thing out. So I've got the Y voltage is molted and going to several different places here. So you can hear the rings and the Atom and the knit, pretty much everything, the Q-Pos, everything kind of, the parameters are changing because I'm using the various outputs on Pachinko, yet I'm also clocking the Quadraturia LFO here in Ornament and Crime from the divided clock here. So I've got in-time LFOs that I'm also molting out everywhere. So to be honest, it's kind of hard to follow what everything here or what everything is doing specifically, but I think you can get the idea. So now let's just mess with some of these parameters on Pachinko to see the difference now that we've learned what they do. So now we're just getting roots and octaves of our scale with this the steps knob all the way up. And now as we turn that down, we'll be slowly introducing more notes from the scale. Now we're going to the higher end of the spread here. I'm going to bring that down to the lower section. So now we've gone from just a +2 voltage to a +5 voltage range. So you can hear a lot more dramatic changes in our CV. And then if we go into now we're getting a bipolar voltage. So that's gonna not be super great. I think the +2 is best for like melodic stuff. And then the fun stuff happens over here. Like I mentioned earlier, if you're in the drum mode, you can get into some stuff that's kind of like drum filly. So let's turn this bias knob all the way to the right, and then you'll see how it starts to favor the snare drum over the kick. And then all the way to the left, it'll do the opposite. It'll favor the kick over the snare. And then, of course, the jitter knob. You can hear it's kind of getting a little laggy, maybe a little swingy. And all the way up, it's just absolute chaos. And then if we get out of the drum mode, you'll hear that it becomes much more of just a random type machine rather than a drum beat creator. And then this is just everything happening equally here, all the triggers. We can do our divisions and multiplications here. So here's our divide by 4 for our clock, and then times 1. Oh, there's times 1. And then times 4. And then we can lock some stuff in there. So now we'll have repeating loops for both the gate and the CV, and then we can do some different determination on how those things that are locked in are going to be reordered. And there you go. That's Pachinko. If you want to learn more, definitely head to the Mutable Instruments manual for marbles, because that's where the action really is. Thanks for watching. I hope this helped. And if you would like to see any of these other modules demoed in the near future, sound off in the comments.